Hey everybody, it's Miss Williams. This is Statistics class, Chapter 3, Describing Relationships, Section 1, Scatter Plots and Correlations. Explanatory and response variables. The response variable measures the outcome of study. The explanatory variable may help to predict or explain the changes in the response variable. So here's two quick questions. How does drinking beer affect your alcohol level? The legal limit for driving in all 50 states is 0.8%. In a study, adult volunteers drank different number of cans of beers. 30 minutes later, the police officers measured their blood alcohol level. Which one is going to be the response variable? Which one's the explanatory? Write that in your notes. The National Student Loan Survey provides data on the amount of debt for reaching college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. Which one would be the response and which one would be the explanatory variables? Put those in your notes and we will discuss that when you get to class. So this is talking about the relationships and scatter plots. Scatter plots measure two different quantitative variables on the same individual. So you have quantitative variables. Think about what those are, not categorical but quantitative. Okay, how do you describe that data? Well, you can talk about its direction. Is it positive or negative? What kind of form does it have? Is it curved, linear, a cluster of points? What's the strength of the data? How close do the points fit into the form that you just described? And are there any outliers, points that fall outside the overall pattern? The data itself can be a positive association. That's when above average values of one variable are associated with above average values of the other. In other words, as one variable goes up, the other one goes up. Or negative association, when the below average values of one variable are associated with the above average values of the other variable. As one variable goes up, the other one goes down. So correlation is denoted with the letter R, and correlation measures the direction and strength of the linear relationship between two quantitative variables. So as you can see, the first one, it's hard to see because I've zoomed this in, but it's a negative 0.9, negative because if I was to draw a line through all those data points, it would be a negative slope. All right. Second one is negative 0.5. The third one going across is 0. And then on the bottom row, positive 0.5, positive 0.9, and then an exact correlation is correlation of 1. So here's some things you need to know about correlation. It makes no distinction between explanatory and response variables. It does not change when you change the units of measure. R has no unit of measure itself. You don't ever want to say R is equal to 0.3 feet or 0.3 pounds. Correlation does not imply causation. Both variables must be quantitative. Correlation only describes linear functions. R is strongly affected by outliers, and correlation is not a complete summary. You must always, when you're talking about describing data, always give mean and standard deviation with describing the relationship. One thing I didn't put on here is that, and we talked about it in class, is that R needs to go, -1 is the smallest R can be, +1 is the biggest R can be. It's always a number between -1 and 1. And the closer it gets to 0, the less of a relationship the explanatory and response variables have. Okay. How do you calculate R in the calculator? Well, the first thing you have to do is make sure diagnostic is on. And we did this by going to the catalog. Hit second 0 to get to the catalog, scrolling down until you find diagnostic on and hitting the enter twice. Your calculator should reply with the word done. Now it's time to put your data in, so hit the stat button, then hit edit, put your x's in L1 and your y's in L2. Now hit stat again. This time arrow over to calc and find linear regression. And finally, you'll hit enter a couple times. Your x will be in L1, your y's will be in L2, your frequency distribution is once. So go down to calculate. The calculator will give you the linear regression along with R and R squared. All right. I know that was really fast. We've been over this in class already, just a refresher if you need it.